Okay, so now let's talk about how we're going to interpret the coefficients of our fitted line. And let's start by talking about w hat 0, our estimated intercept. So that's this point right here, this green star. And what does that represent? Well, it's the predicted value of a house with 0 square feet. So we can think of that as just land, because we have that y hat is equal to w hat 0 when x equals 0. So when there's no square feet, we have that our predicted house value is exactly equal to w hat 0. But I'll say that in general, this is not normally that meaningful. In many scenarios, you don't really think of having no input and having the output have some meaningful value. And actually, in our case, if you go back and look at the number, we had that our intercept was minus 44,850. So it's saying that land, you should actually, as the seller, be giving the buyer money to take that land off your hands. But remember that our data set's really noisy. It's not a perfect model of what's going on. So of course we have to think about interpreting our parameters in the context of what we've included in our model. Okay, we'll talk more about that in the next module, but I also want to talk about w hat 1, which is our estimated slope, and that tends to have a bit more meaning associated with it. So the estimated slope, I'm highlighting with this green triangle here, saying that per unit change in our input, so for 1 unit, so 1 square foot, what's our predicted change in the value of the house. So for example, let's say I'm looking at estimating the value of a house with 1,001 square feet. And I want to look at the difference relative to the estimated value of a house with just 1,000 square feet. Well, what is this? This is equal to, if I look at the first term, estimating a house with 1,001 square feet, how would I estimate that? I'd take w hat 0 plus w hat 1 times 1,001 square feet. And then I'm going to subtract, for the second term, I have its estimated value is, again, w hat 0 plus w hat 1 times 1,000 square feet. And these w hat 0s are going to cancel, and the difference between these numbers is just 1, so this will just be w hat 1. So again, w hat 1 represents the predicted change in the output per unit change in the input. Okay, so that's how we're going to interpret w hat 1. But one thing I want to make very, very clear is that the magnitude of this slope depends both on the units of our input and on the units of our output. So in this case, the units of slope are square feet per, are dollars per square feet. And so if I gave you a house that was measured in some other unit, then this coefficient would no longer be appropriate for that. So let's make this a little bit more explicit. So now that we know that there are units attached to these numbers, I'm going to put these in. So our intercept has units just dollars. So let me be clear what I'm actually highlighting here. The intercept has units dollars, and the slope has units dollars per square feet. And when I went through and did my calculation of predicting the value of a house with a given square feet, if I actually put in these units, I see that everything works out. Here I have dollars, here I have dollars per square feet, and then I'm multiplying by square feet. So when I multiply these two things, the resulting units of this is just going to be dollars. So the end result is something in terms of dollars. That's great. And likewise, when I use the equation in reverse, I have dollars divided by dollars per square feet, and I end up with something that's in square feet. So I'll just say units work out, which is great. But what if the house was measured in square meters instead of square feet? Well, clearly I can't just plug into that equation. And likewise, what if the price was measured in Chinese yuan instead of in US dollars? Again, can't just plug into that equation. So when I think about the magnitude, it only has meaning in terms of the units that I've used for my input and output.